Today we're going to talk about the law of cosines. This is also another way that we're going to use to solve non-right triangles. To solve right triangles, you want to use the Pythagorean theorem and SOHCAHTOA. So we're going to use this picture at the right. Now, because this point here is PQ, P is the x-coordinate, so this is what P is. And Q is the y-coordinate, so you go up Q. This whole length is C units. So this little piece in here is C minus P. We're going to need that in our example today. So use triangle ACD. So use ACD to write expression for P squared plus Q squared. P squared plus Q squared, well, that's the Pythagorean theorem. P squared plus Q squared is going to equal B squared. And for P, in terms of B, an angle A. Well, P is the adjacent side, B is the hypotenuse, so the cosine of angle A is P over B. If I multiply both sides by B, then we get P equals B times the cosine of angle A. So we're going to need both of those for the third question. Find A squared in terms of C, P, and Q. A squared, well, that's the hypotenuse in triangle DBC. So A squared, the hypotenuse squared, is equal to Q squared, one of the legs, plus C minus P squared. Multiplying that out, C squared minus 2CP plus P squared. So now we want to use our results to find an expression for A squared in terms of BC and angle A. So A squared, BC, and angle A. Well, let's look at this. Q squared plus P squared is B squared. So that's going to be B squared. So I have, in terms of B, C, just bring down the plus C squared, minus 2, well, P is B times the cosine of A. So side C times side B times the cosine of angle A. So we've derived our law of cosines. So our law of cosines is used when you're given at least two sides. So side, angle, side, or side, side, side. So in any non-right triangle, I'm going to say ABC. Side A is opposite of angle A. Side B is opposite of angle B. Side C is opposite of angle C. So our law of cosines, and I expect you to remember this, is A squared is equal to the other two sides squared, B squared plus C squared minus 2. Now just look at the right side, 2B times C times the cosine of angle A. Notice the only time that you see the A is on the two opposite sides of the equation. So then similarly, B squared is going to equal the other two sides squared minus 2AC. I just look A times C times the cosine of angle B. Now C squared is equal to the other two sides, A squared plus B squared minus 2AB cosine of angle C. And yes, you need to know those, but I don't think that they're too bad to memorize, especially since we derived it, and they kind of look like the Pythagorean theorem. So use the law of cosines to solve the triangle. This is a side, side, side example because I'm given all three sides. So we need to find the angles. So it doesn't matter which angle you find first. Let's find angle A first, as it comes first in the alphabet. It doesn't matter. So set up your law of sines. Since we're solving for angle A, it's A squared equals B squared plus C squared minus 2BC cosine of angle A. Well, angle A, that's going to be our variable. So A squared, 23 squared, equals B squared, which is 32 squared. C squared is 27 squared minus 2 times 32 times 27 times the cosine of angle A. Now, what you have to do, this piece here at the end, that's all one term. So you can't combine the 32 squared and the 27 squared with that. So what I do is I subtract it over to the other side. I do 23 squared minus 32 squared minus 27 squared equals negative 2 times 32 times 27 times the cosine of angle A. Now what you want to do is grab your calculators so that we can find what that is. Okay, so I wrote the equation that we needed up there. So 23 squared minus 32 squared minus 27 squared equals. So you get negative 1,224 equals. Now get what negative 2 times 32 times 27 is. That's negative 1728 cosine of A. Now divide by negative 17,028, negative 17,028. That's going to get you the cosine of A. So that decimal, negative 1, 4, divided by negative 1728. Press enter. So that's 0.7083 repeating. Don't delete that. That is not your angle measure. What you need to do is you need to do the inverse cosine of that angle, of that answer, to get what angle A is. So we do the inverse cosine of that answer because I want the most exact answer, 44.9. So angle A was 44.9. Now you need to set up your law of cosines again to get angle B or angle C. It doesn't matter which one you find next. Let's go with B. B squared equals A squared plus C squared minus 2AC cosine B. You might want to rewrite that formula out a few times so that you get accustomed to using it. B squared, that's 32 squared, equals A squared minus C squared minus 2AC cosine of B. Now again, subtract those pieces over. That should be a plus sign. Subtract those pieces over. And find what that is. And solve for B. So I'm going to jump again back to our calculator. Okay, so I've written the formula that we need up. Type it in your calculator. 32 squared minus 23 squared minus 27 squared. Get that value. That's negative 234 equals. Get what negative 2 times 23 times 27 is. Negative 1,242 times the cosine of B. Now remember to divide. Because remember, that's standing for the cosine of angle B. That's not what the actual angle is. Negative 234. Make sure you don't forget your negative. Negative 1,242 So that's what the cosine is, 0.188. Do the inverse cosine of that answer. Inverse cosine of that answer. To get our angle of 79.14. Now angle C, you don't have to do the law of cosines again. Angle C is 180 minus 44.9 minus 79.14. So angle C ends up being 55.96. Our next example is when we're given side angle sides. So two sides and the angle included in between. You need to find side B first. So we have angle A we're trying to find, angle C, and side B. Set up your law of cosines right away to find side B. B squared equals 94 squared plus 45 squared minus 2 times 94 times 45 times the cosine of angle B. Oh, we know angle B, 72. You can just type this in your calculator as you see it there. Remember that you're looking, that when you type that in your calculator, you have B squared. So let's type that in our calculator. So type that in your calculator exactly how you see it. 94 squared minus 45 squared minus 2 times 94 times 45 times the cosine of 72. Close the parentheses, press enter. Now remember that's b squared, so we need to square root it. Second, x squared is your square root button. That answer, close your parentheses. So b is 64.78. B is 64.78. Now you need to find either angle A or angle C. And you need to use the law of cosines here. So let's find angle A. Angle A squared equals b squared plus c squared minus 2bc cosine of angle A. We know side A is 45. B squared is 64.78 squared. C was 94 squared minus 2b times c times the cosine of angle A. So this is just like we did in the last problem. So go to your calculator. I'll have that on the calculator here in a minute. So I've written the formula that we have. So you want to do 45 squared minus 64.78 squared minus 94 squared. Now take and simplify the other side, negative 2 times 64.98 times 94. Negative 12216.24 times the cosine of A. So divide those two answers. Doing a quick check to make sure you have both of them negative. I'm just going to pull up the previous answer. And then I'm going to do the inverse cosine of that answer to get 25.7. So angle A was 25.7. Already in the picture, we know angle B was 72. So let's subtract from 180. 180 minus 25.7 minus 72 to get angle C to be 82.3. So we had 82.3. And then for the other angle, we had 25.7. 25.7. There are your two lesson questions for the day. Please make sure those are submitted on time.